So we're going to start our second day of 6EE2. Previously we talked about how to translate words and phrases into expressions. So we're still going to use those terms like sum, difference, product, quotient, numeric expression, algebraic expression, but now we're going to talk about what inside an algebraic expression or numeric expression is a term, a coefficient, what are like terms, what are constants, and then we are going to also go over what are variables. All right, so taking a look at some of our vocabulary terms, we have 5 terms here. I'd like you to take a minute and try to match these up on your own, and then when you come back, we'll take a look at your answers. All right, so here I have an algebraic expression. None of the first 4 can be algebraic expressions because they all are referencing a number or a term, and none of them reference it being a sentence. So an algebraic expression has to be a number sentence. The only thing I'm going to add to this is that there also has to be at least one variable, because to be algebraic, it has to have that variable. Okay, so the first one should be E. Then a coefficient. So the coefficient is a known number that is a factor of a variable. So plain and simple, the coefficient is what the variable is being multiplied by. So when I see 4x, the coefficient is the 4. Okay, a constant is a term that is a known number without variables. So it doesn't change. It's constant. It stays the same all the time. It's never going to be replaced by a different number. Okay, a term is a known number, a variable, or the combination of the two inside of an algebraic expression. So A. So if I have like 4x plus 6, my terms are 4x and 6. And then the variable is the letter that stands for an unknown number or a number that can change. All right, so let's see what these look like inside of expressions. So here we have a couple of expressions. I have, in my first one, I actually have 3 terms. So I have 4x, 3y, and 7x. Each of those is a term within the expression. The variables inside of my expression. Now I know I see variables in 3 different places, but there's actually only 2 variables. I don't have to list the x twice because it's just representing one number. So if x is equal to 2, then I would put in a 2 here and I would put in a 2 here. The coefficients here are going to be 4, 3, and 7. Those are the numbers that are multiplying our variables. And there are actually no constants in this case because you don't see any numbers without variables attached to them. Like terms. Now this is where we tend to struggle. All constants are like terms because they have no variables. So that's pretty plain and simple. We tend to combine those constants though with terms that have variables, and we can't do that. So we're really going to focus on what like terms actually are. Like terms are terms that have either the same variable with the same exponent, or no variable. So in this case, I have 4x and 7x. They both have the same variable, so they are like terms. Other examples that I have in here, so I have a sum, and the sum is my 4x plus 3y. And then I also have a difference, and I can be super specific here and say that my difference is going to be my sum minus 7x. All right, so let's take a look at the next one. Again, I have 3 terms. I have 2x squared times 3x. Oh, why did I put the times in there? I'm just rewriting the whole thing. My goodness. No multiplication symbol needs to go in there. I apologize for that. I don't know why. My screen is going a little haywire here. Okay, back on track. So I have 2x squared, 3x, and 17 are all terms. My variables, again, even though the x is squared, it's just the x that's the variable. So my x and my x, same variable, so I only list it once. My coefficients are 2 and 3. And I do have a constant this time. I have 17 that does not have a variable on it. Now, like terms. Remember I said it has to be not only the same variable, but if that variable has an exponent, it has to be the same variable with the same exponent. Here, I have an exponent of 2, and here, it's not that I have no exponent, it's technically an exponent of 1. So they're not the same. So I actually don't have any like terms. I do, however, have an exponent this time, and my exponent, I think I forgot a letter in there. Yep, there we go. My exponent is 2. I have a product, and that product is 2x squared times 3x. And then I also have a quotient this time, and that quotient is going to be my product divided by 17. I have 2 more problems here that I'll go over with you. You're more than welcome to try them on your own and then come back and check your work, or you can go through them with me. Either way, you are going to try this last one by yourself and then come back and check it, so that way you have an idea of how you're doing with each of these pieces. All right, so here I have terms. My terms are 1/2 x, 3y, and 7. I have 2 variables this time. I have x and y. Now I have a coefficient this time that's a fraction, and that's okay. My coefficient is 1/2, and the other coefficient is 3. I do have a constant this time. It's 7. And again, I have no like terms because I have no variable, y, and x. So I have no 2 terms that have a common variable or no variable. So none. The others in this case, I do have a sum. My sum is going to be that 1/2 x plus 3y. And then I will have a difference, and that difference is going to be my sum minus 7. All right, last one. Like I said, you're going to try this on your own for sure and then come back and check your work. So my terms are 2x squared, 3x, and then 17. I only have one variable, and that's x. Now, I know I said that we talked about like terms. They have to be the same variable, same exponent. When it's a variable, x and x are the same. The exponent doesn't matter. They only come into play when it comes to like terms. My coefficients are 2 and 3. My constant is 17. I don't have any like terms though because I don't have I have an x squared, an x, and then nothing, so I don't have anything that's the same. I do have an exponent again, and this time I spelled it right, so we're on the right track. And I have a product, and my product is going to be 2x squared times 3x. And then I also have a sum, and that's going to be that product, and I'm adding 17 to it. All right, so I would like you to add this expression to the bottom of your notes, and you're going to go ahead and identify, or even on the back page of your notes, and you're going to identify the different parts of this expression. I do want to add a piece on here of, let's say, 3x squared. All right, so you're going to try this one, and then we'll go over it when you guys come back to class.